Welcome to the DIY Honda Garage channel. DTC B1906 pertains to the communication failure between the Immobilizer-Keyless control unit and the gauge control module within the Honda Civic models from 2006 to 2011. The immobilizer system is crucial for vehicle security, preventing unauthorized access and ensuring that only the correct keys can start the engine. The keyless control unit is designed to facilitate this process by relaying information to various electronic systems, including the gauge control module, which manages the vehicle's dashboard readings like speed, fuel level, and battery health. Located near the vehicle's dashboard, the gauge control module processes inputs from various sensors, making it essential for the vehicle's operational awareness. A breakdown in this communication can lead to vehicle performance issues or the inability to start. Proper diagnosis and repair are vital to restore full functionality and ensure safety. DTC B1906 indicates a communication loss between the Immobilizer-Keyless control unit and the gauge control module, also known as the tachometer. The Immobilizer-Keyless control unit is responsible for acknowledging the correct key and enabling the vehicle's engine to start. It sends signals to the gauge control module, which is mounted on the dashboard, to display accurate information to the driver. If these two units cannot communicate effectively, the gauge control module may fail to receive essential data, leading to incorrect readings or warnings. This communication failure can cause the vehicle to enter a security lockout state, preventing engine start. Understanding the roles and locations of these components aids in effective troubleshooting and ensures proper repair procedures are followed. Potential causes for DTC B1906 can stem from a variety of sources. A faulty Immobilizer-Keyless control unit could disrupt communication, necessitating replacement. Likewise, if the gauge control module itself is malfunctioning, it may not correctly interpret or send data. Wiring issues, particularly poor connections or damaged wires between these two components, can also be significant culprits in disrupting the communication pathway. Each of these issues demands thorough inspection to pinpoint the root cause effectively. If several DTCs appear, one must follow the BCAN System Diagnosis Test Mode A to ensure that all systems are evaluated in synchronization with Honda's diagnostic standards. Recognizing these causes allows technicians to narrow down their troubleshooting efforts efficiently. Symptoms associated with DTC B1906 may manifest as various dashboard warning lights without any corresponding issues. These lights signal to the driver that there is a problem within the electronic systems. Another likely symptom is the inability to start the engine. This situation arises when the immobilizer system detects an issue with the key or communication loss, preventing the engine from receiving a start signal. Additionally, erroneous gauge readings may occur, indicating incorrect speed or fuel levels, which could mislead the driver. Therefore, these symptoms can compromise both the driving experience and vehicle safety, making immediate diagnosis crucial. Understanding these symptoms allows for timely intervention and resolution of the underlying issues. The first step in troubleshooting DTC B1906 involves using the Honda Diagnostic System, commonly known as HDS. By connecting to the vehicle's onboard diagnostics, technicians can clear any existing diagnostic trouble codes. This step is critical to eliminate any stored error information that may have been present due to transient issues. Once the codes are cleared, it is essential to follow up by turning the ignition switch from lock to on. This action helps to reset the vehicle's systems, allowing them to run a self-diagnostic check. Waiting at least 6 seconds before performing the next diagnostics ensures that all systems have completed their initialization processes. This creates a clean slate for accurately assessing the presence of DTC B1906 and determining if further issue resolution is necessary. In the second step, after clearing the DTCs, the technician will turn the ignition switch to the lock position and then back to the on position. This action prepares the vehicle for another diagnostic check by reinitializing the electrical systems within the car. The importance of waiting at least 6 seconds cannot be overstated. It allows the onboard systems to fully initialize and check for any faults. Following this wait time, one will then be prepared to check for DTCs again using the HDS. It's critical to ensure that all systems are refreshed, as any lingering codes from previous errors could lead to redundant troubleshooting steps, ultimately prolonging the diagnostic process. Such meticulous attention ensures efficient troubleshooting and accurate verification of the DTC status. In the third troubleshooting step, you will again use the Honda Diagnostic system to check for the presence of DTCs after the initial clearing process. Specifically, you are looking to see if DTC B1906 is re-indicated. If the DTC reappears, this signals that the communication issue between the Immobilizer-Keyless control unit and the gauge control module persists. This could signify underlying issues in either of these units or the connectivity between them. If DTC B1906 is not indicated, the problem may be intermittent or resolved for the moment. In this case, continued investigation is necessary to find any loose connections or poor wiring that could have initially caused the error. Effective interpretation of DTC results is pivotal for the next steps in troubleshooting to determine the root cause of the problems. Upon confirming the presence of DTC B1906 in the previous step, you would proceed to the next stage of troubleshooting. If DTC B1906 is indeed indicated, it's crucial to continue with further checks outlined in the diagnostic protocol. In contrast, if the code is not present, this suggests an intermittent failure or that the system is functioning correctly at that moment. Understanding that intermittent failures can often be perplexing, attention should be directed to inspect loose or poor connections at the gauge control module's 36P connector and the 7P connector of the Immobilizer-Keyless control unit. This understanding can lead to identifying the fluctuations that led to the original error, promoting a more thorough investigation of these critical connections. Such sensitivity in diagnostics makes reliable servicing easier and enhances the longevity of vehicle components. The fifth troubleshooting step involves another action with the ignition switch. The technician will turn the ignition switch to the lock position and then back to the on position to refresh the electrical systems again. This step ensures all connected components are reset and primed for the diagnostic check to follow. After this, one navigates the Body Electrical System Select menu within the HDS to access the BCAN Control Units information section. This is where you can review connected control units to determine the operational status of the gauge control module. By selecting Check Connected Control Units, it enables the technician to understand whether the gauge control module is functioning correctly within the network of control units. This is crucial as it determines the next steps in the troubleshooting process based on the module's status. In this sixth troubleshooting step, you will check the connected control units by selecting the appropriate option in the HDS. This action allows the technician to review the condition of the gauge control module, which is essential for proper functionality within the vehicle's electronic system. If the display indicates that the gauge control module is not available, it indicates a communication failure persisted between the control unit and other systems. This is a crucial finding, as it directly influences the diagnosis of the underlying communication problem. On the other hand, if the module's status is available, it suggests that communication is intact, prompting the technician to consider replacing the Immobilizer-Keyless control unit as the next step. Verifying the status of the gauge control module is a vital part of diagnosing communication-related DTCs. Executing the input test on the gauge control module is fundamental in this 7th troubleshooting step. Here, you must determine whether all inputs are functioning appropriately. If all inputs report is okay, this suggests that the gauge control module may not be at fault and indicates that you can proceed to the next diagnostic step. If the inputs are not okay, this hints at an issue within the gauge control module or the signals it receives. Proper handling of this testing phase is essential. It establishes the input integrity upon which the rest of the vehicle's diagnostics depend. Evaluating input signals allows technicians to streamline their focus either on repairing the gauge control module or identifying root causes of the failures. This careful examination supports accurate repair strategies and reduces unnecessary component replacements. In the 8th step of troubleshooting DTC B1906, proceed by disconnecting the Immobilizer-Keyless control unit via its 7P connector and the gauge control module, TAC, through the 36P connector. This step is essential for isolating the components for further testing and verifying their integrity. Once disconnected, it's crucial to check for continuity in the wiring between these units, as faulty wiring can often be the silent cause behind apparent electronic failures. Properly checking these connectors ensures that intermittent failures due to poor connections are identified early in the diagnostics process, significantly streamlining repairs. The act of disconnecting these components prepares them for further tests to determine their operational capabilities. Establishing a clear path for diagnostics prevents unnecessary confusion and allows for methodical troubleshooting to take place. At this step, you will conduct a continuity check between specific terminals of the Immobilizer-Keyless control unit and the gauge control module. Specifically, this involves checking the continuity between terminal number 4 of the 7P connector on the Immobilizer-Keyless control unit and terminal number 21 of the 36P connector on the gauge control module. If there is continuity, it confirms that the wiring between these two components is intact, leading to the conclusion that the gauge control module may need replacement, as it may have failed after causing communication issues. If continuity is absent, however, it suggests there's an open circuit and you'll need to repair the wiring between the two units. This step is critical as it directly affects communication and operational integrity and must be handled with extreme attention to detail to ensure accurate repair procedures are followed. After completing the necessary repairs recommended in previous steps, the final verification must be conducted. This involves rechecking the status of the DTCs using the HDS to ensure that all codes, including DTC B1906, have cleared properly. Additionally, testing the functionality of the repaired components is vital to ensure they operate as intended. Verifying that the communication between the Immobilizer-Keyless control unit and the gauge control module is re-established effectively. Successful completion of this verification step guarantees that no underlying issues persist and that both components are now fully operational within the vehicle's electronic system. It is also advisable to perform a brief road test to ensure that functionality is restored under typical driving conditions. Final verification confirms the integrity of the repair process and promotes long-term reliability for the owner of the vehicle. Preventive maintenance is key in avoiding future occurrences of DTC B1906 and in promoting overall vehicle longevity. Regular checks of electrical wiring connections, especially around the Immobilizer-Keyless control unit and gauge control module, can help to identify and resolve potential issues before they lead to significant failures. This includes inspecting for signs of corrosion, damage, or signs of wear that could interfere with electronic communication. Additionally, maintaining cleanliness around the components can prevent dust and debris from obstructing connections and causing intermittent failures. Implementing routine diagnostic scans can also uncover any emerging DTCs that can be addressed early. These proactive measures not only enhance the performance of the vehicle, but also ensure greater safety and reliability for daily driving needs. In conclusion, DTC B1906 represents a significant communication failure between the Immobilizer-Keyless control unit and the gauge control module in Honda Civics from 2006 to 2011. Recognizing the symptoms, possible causes, and systematic troubleshooting steps is essential for accurate diagnosis and repair of this DTC. Intermittent failures can lead to further complications if not addressed promptly with good diagnostic practices. Effective repairs depend heavily on understanding the role and functions of the involved components, coupled with rigorous checks of wiring and connections. Preventive maintenance can play a crucial role in reducing future issues, making it a worthwhile investment for vehicle ownership. Engaging in a thorough process from diagnosis through to preventive strategies helps ensure long-term functionality and safety of the vehicle. Please like and subscribe to the channel. See you next time.